Hi, this is my AP Chemistry partial pressures tutorial. So the problem is that assume that in a 4 meters cubed balloon there are three gases present. These gases are hydrogen, H2, nitrogen, N2, and oxygen, O2. The entire balloon contains 2.1 kilograms of gas with the percent composition of the gases as 30.48% oxygen, 2.86% hydrogen, and 66.67% nitrogen. Now, at 0 degrees Celsius, what is the total pressure of the balloon and what are the partial pressures of the three gases? So the first step is to figure out how many moles of each gas are present. After we figure out how many moles of each gas are present, we will then have the total amount of moles present, and as a result we can find the total pressure of the system using the equation PV equals nRT. Then we can figure out the mole ratios of each gas, and then we can use the total pressure that we found in the previous step to finally find the partial pressures of each gas. So first and foremost, we need to figure out how many moles of each gas are present. We can do this by using the percent compositions by mass given to us. So we have 2.1 kilograms of total gas, which is equal to 2100 grams of gas. So we can multiply this by 0.3048 to find the mass that oxygen comprises. So if we carry out this calculation, we get 640 grams. 640 grams of oxygen. Now we need to find the molecular mass of the oxygen gas, since each oxygen weighs since one oxygen atom weighs one sec. So the mass of one oxygen is 16 grams, so two oxygens would then be 32 grams. So we need to divide our 640 by 32 to get 20 moles of oxygen. Next, we just carry out the same process for the other two gases. So 2100 times 0.0286 gives us 60 grams of hydrogen. Now the molecular weight of one hydrogen atom is 1 gram. So since hydrogen gas is a diatomic molecule, that means the gas's molecular weight is 2 grams. So we do 60 divided by 2 grams, which gives us 30 moles of hydrogen that is present. Finally, we do this step one more time. So 2100 times the percent of the nitrogen, which is 66.67, so that's multiply that by 0.6667, which gives us 1400 grams of nitrogen. Now, since one nitrogen atom has a molecular weight of 14 grams, two nitrogen atoms would have a weight of 28 grams. So if we divide 1400 grams by 28, we get 50 moles of nitrogen that is present. So now we've completed step one. We figured out how many moles of each gas are present. So now we need to use the total amount of moles to find the total pressure of the system. So we have 30 moles of hydrogen, 50 moles of nitrogen, and 20 moles of oxygen, and that gives us a total of 100 moles. 100 moles. And in the equation PV equals nRT, this is equal to N because N is the number of moles present. So now I'm just going to erase all this. Okay. Oops. I accidentally erased my instructions. But anyway, so we have PV equals nRT equals nRT. So the pressure is what we need to figure out. So P times V, and our V is 4 meters cubed, is equal to nRT, and N is the number of moles. We just figured out we have 100 total moles. 100 moles total times our R, which is 8.3145 according to these units, because the volume is not liters, it's meters cubed, so our R has to be different to account for the units. And then our temperature is 273 Kelvin. Using all this information, we can figure out the total pressure of the system, which is, give me 1 second. So we have 100 times 3145 times 273. So this gives us 56,746.46 pascals. Now the unit is pascals because of the R that we used and the Kelvin and the moles, and since the liters is in meters per cube, the pressure is in pascals. So now we can convert this into ATM by dividing by 101,325 pascals. This is because 1 ATM is equal to 101,325 pascals. So if we do this calculation, we get 0.56 ATM. So that is our total pressure. So again, the total pressure of the system is 0.56 ATM. Now using this, we can finally find the partial pressures of the three gases. So let me go to new page. So total pressure. Total pressure is equal to 0.56 ATM. So now we can use the equation for partial pressure, which is equal to the mole ratio. So the mole ratio of each individual gas is equal to the partial pressure of that gas over the pressure of the whole system. So I kind of erased the moles of each gas, but I'll write them again. So the moles of hydrogen that we have is 30, and then moles of nitrogen that we have is 50, and the moles of oxygen that we have is 20. So first we can do hydrogen. So the mole ratio of hydrogen would just be the moles of hydrogen, which is 30, over the total number of moles, which is 30 plus 50 plus 20, which is 100. So this is equal to the partial pressure of hydrogen. This is what we're trying to find, over the total pressure, which we just found. So it's over 0.56. So if we cross multiply and everything, we can find the partial pressure of hydrogen to be 0.56 times 0.3 equal to 0.168 atm. Again, we can do this for nitrogen now. So 50 over 100, which just simplifies to 1/2, is equal to the partial pressure nitrogen over the total pressure 0.56. So the partial pressure of nitrogen is equal to 0.56 times 0.5, which is equal to 0.28 atm again. Finally, for the oxygen, we can do 20 over 100 is equal to the partial pressure of oxygen over 0.56 atm. So finally, the partial pressure of oxygen, oxygen is equal to 0.2 times 0.56, which gives us 0.112 atm. So these are our partial pressures, and we also have our total pressure, which is this. So now we can double check our answers by adding up all the partial pressures and making sure they equal the total pressure. So if we do 0.168 plus 0.28 plus 0.112, we do indeed get 0.56 atmospheres. So, yep. So we finished the whole problem.